All right, good morning, you guys. Today we're looking at statistics, binomial distributions using the graphing calculator. So first up, this is a big day of shortcuts, so hopefully we're excited about that. So Binome PDF. So Binome PDF is just an abbreviation that we use for binomial probability density functions. Okay, just to make it user-friendly, this is where we use our calculator to calculate exact probabilities for certain outcomes. So for example, if I wanted to calculate exactly 3 heads out of 10 coin tosses, I would be using the Binome PDF function in my calculator. So here, let me just write a little note. We use, for calculations, of exact probabilities. And like I said for my example, this would be like looking for exactly 3 heads when we flip a coin 10 times. So we'd be looking for exactly 3 successes. All right, Binome CDF, here we're looking at a binomial cumulative probability density function. So this, let's see, let me change my notes. This should say CDF. Let me just do a little fix it there. So the abbreviation of CDF is used for binomial cumulative probability density function. Okay, so cumulative, we've heard that before, right? We know that that just means we're looking at a running total. A running total up to a given point. So running total. Okay, so we use this for calculations of probabilities over a spread of values. So let me give you an example so that that makes sense. So if I'm flipping a coin 10 times and I'm interested in the amount of heads, what's the probability that I get 3 or less heads out of those 10 coin tosses? This is an instance where I would be using the cumulative probability density function. So it would capture the probability of exactly 3 heads or anything below that. All right, so we use, for calculations of probabilities over a spread of values. Okay, and then in my example, again, I'm having us flip a coin 10 times, and I'm saying what would be the likelihood, the probability of getting 3 heads or less. So that would encompass exactly 0 heads, exactly 1, exactly 2, or exactly 3. So it's looking at 3 heads or anything below it. So my success, I'd be looking at exactly 3 successes or anything below that, anything less than that. So I'm looking at it as a spread of possible values, right? X could be 0, 1, 2, or 3. All right, so when I use my functions in the calculator, it's just important to know where we find them. So first, let's just write that down. So to get there, and I'll show you with my calculator just a moment, I'm hitting second vars. That takes me to my distributions. And from there, I'm looking for Binome PDF, and I'm looking for Binome CDF. So 0 for my calculator would be the Binome PDF function, and then the A would be the Binome CDF function. And I'll show you all of this in just a moment. So the N, when we use the PDF function, the N is just our total number of trials. So number of total trials. The P is our probability of success. And the X is our count of success. It's our number of successful trials. Okay, and then when we use Binomial CDF instead, the N is still the number of total trials. Okay, and then the P is still probability of success. And the X, here we're looking at or below this number of successful trials. So again, if I go back to my example here versus here, I would use PDF here if I'm looking for exactly 3 successes. So remember my scenario. I had us flipping a coin 10 times, and I'm looking for the probability of getting exactly 3 heads. So if I was plugging this into my calculator, I would have 10 total trials. My probability of success would be 0.5, and I'd be looking for exactly 3 heads, exactly 3 successes. Okay, if I was using Binomial CDF over here, this would be, again, I'm flipping a coin 10 times, and I'm looking at exactly 3 heads or less. So I would have right here 10 total trials. My probability of success, 0.5 for getting a head. Okay, and then here I'm looking for exactly 3 heads or below. So this will capture 0, 1, 2, or 3 and add them all up. Remember, cumulative means it's a running total. All right, so next up here, I'm just going to show you how we can graph it in the calculator just to visualize what it is that we're actually doing. So we're trying to create a binomial probability distribution, right? I just want to visualize it just like we've been doing as we graphed our discrete probability distribution. So now we're looking at it just, what does it look like when it's binomial? So suppose our random variable x arises from a binomial experiment. We're saying n is 15, that's our total number of trials. The probability of success is 0.53. We want to make a histogram, include the window settings, describe our shape, find mean, standard deviation, and then calculate the following probabilities. So first up, I'm just going to define what n is. So I'm going to say, okay, well, n, I got 15 trials. My probability of success will be 0.53. So failure would be its complement, 0.47. And then what are the values that the random variable could take? Well, it could be nothing, could be everything, or something in between. So it could be exactly 0, could be exactly 1 or 2, all the way up to 15. Okay, so then I want to make a histogram. So I want to figure out what my probability distribution is going to look like. So here I'm going to make a little table off to the side just to keep track of what I'm going to see in my calculator in just a few moments. Okay, in the L1, I would like you to type in the values that the random variable could take, 0 through 15. So I'm just going to keep track of this to the side. I'm just going to record a few of them, and then all the way up to 15. There. So let me go to my list. Let me go here first. So I'm going to hit Stat, Edit, and I'm going to take a moment, and I'm going to clear out my lists. Remember, we clear, we do not delete. Okay, over here in the L1, I'm just going to type in 0 through 15. There's a way that I could have my calculator just build me that string of values too, but I think it's probably a little faster right now to just type it in ourselves. Okay, so I've typed in 0 through 15. Okay, those are the values that the random variable can take. I can have 0 successes, I can have all 15 successes, or something in between. Okay, now up in the L2, this is going to be the first time that we use the Binome PDF function. So up here in the L2, I have it nice and black, I have it highlighted, and now I want to do second vars. So second vars right here will take me to my distributions. So second vars. Okay, I'm going to scroll down for my Binome PDF right there. Boom, just like that. And then what I'm going to type in, I'm going to type in the n value of 15, comma. I'm going to type in the probability of success, the 0.53, comma. And then I want to let it know to look at the L1 because the L1 is where I have all of my possible random variables, all the possible counts of success, 0 through 15. So second 1, just like that, there's my L1. So again, I have Binome PDF, the N value, the P value, and the X value, which is all the way over in my L1. So right over here, just to make sure we see it, right, I wrote Binome PDF, the N value is 15, the P value is 0.53, and the X value, I'm looking at the L1. So when I hit enter, it's going to show me all of those different probabilities. So here I see that, for example, if I'm looking for exactly 4 successes, that probability would be 0.0266. I'm just going 4 decimal spots. Okay, all of these up here, when I see that scientific notation, that just tells me that it's really unlikely, right? When I see that 10 to the negative 5th power, I move my decimal 5 positions to the left. So if I wrote that in a decimal form, that would be like saying 0.0000 and then 1, 2, right? So very unlikely, because when I move that decimal 5 slots to the left, right, that means it's going to be point and then 4 zeros, 1, 2. So very unlikely, very unusual for that scenario to play out. The next one would be like 0.0002, still very unlikely. Here would be 0.0016, 0.0079. Okay, and then I'm just going to go up to what 15 was. And as I scroll through, I'm really just looking for what is the biggest probability that I see. And it looks like this guy right here, that 0.20297. That looks like that's the highest probability that I'm showing. But I'm just going to trace through and just check one more time. Yep, that looks about right. So this guy at the bottom, that probability of exactly 15, again, I'm going 5 slots to the left. So that would be 0.000073. Okay, so I want to visualize my probability distribution as a histogram. So what I'm going to do next is I'm going to go to my window right here. Here's my window, and I want to make sure I have it set. So I'm going to go 0 to 16. I'm always going 1 more than whatever my N value is, right? My N value is 15, so I went 1 more, and I'm going to scale it by 1s. My Y values, I'm going to make it go 0 to, let's see, I'll say 0.25 because my largest probability was 0.2 something, and then I'm going to scale it by 0.05. So that seems appropriate. I also have to make sure that my plots are set to histogram. So I'm going to go back to my stat plots, second Y equals. That first one, I'm going to hit enter. So I want to make sure that it's on histogram. So I want to change it to histogram, make sure that it's on. My X list is L1, and my frequency is L2. It's really a relative frequency that we have in the L2. Okay, once everything is set, then I can hit graph, and then here is what it looks like. So I'm going to take a moment, and I'm just going to sketch that onto my paper just so I can visualize it. And pull that to the side. So I have that big peak kind of in the middle, and then I'm tapering off the sides. Again, a sketch is fine. I'm just trying to get you used to looking at what the distribution actually looks like. Okay, and then on this side, it's going to taper down as well, like this. Kind of like that. Okay, so there's my picture of it. I'm going to record my window settings off to the side. So that was 0 to 16. Again, it was 1 more than the N value. My N value is 15. I'm scaling it by 1s. My Y min was 0. My Y max was 0.25. And this is really contingent on what was the biggest probability that I had. I just want to go a little bit above it. And I scaled it by 0.05. Okay. Now, if I describe it, I would say, well, it's unimodal. Right, we see that one central peak. Where is the peak about? I'd put it at about 8, and then I'd call it symmetric. So symmetric, I could even tuck in that it looks pretty bell-shaped as well. I know that's usually what we picture when we call something symmetric. Okay, so then I'm saying, well, let's find the mean and the standard deviation. So let me slide this up for a moment. Okay, so my mean is going to be N times P, and my standard deviation will be the square root of NPQ. On a quiz, I will give you these formulas. I don't need you to memorize them, but I'm guessing that most of you will because it's pretty easy. So I'm plugging in 15 for the N times 0.53 for the P. And I'm going to get a mean that is exactly 7.95. So that's my average. So that makes sense. Since my peak was right here at 8, right, it makes sense that my mean is in that ballpark right in here. Okay, my standard deviation, so a good measure of variability. How far away from the mean does a typical value fall? So here my standard deviation, square root of 15 times 0.53 times 0.47. So I'm getting a standard deviation of about 1.933. Okay, and then if I just summarize, well, what does that actually mean? Well, in a sample of size 15, right, that's our N value, we expect an average of 7.95 successes with a standard deviation of 1.933. Okay, so that's what all of that means, and now we're asked to make some calculations. So here we're going to be using the Binome PDF, Binome CDF functions. So first up, I'm looking at what's the probability of getting exactly 5 successes. So here it's exact. So I'm using Binome PDF. Let me write out what I'm going to type in. So Binome PDF, because it's exact. And then I'm saying here's my N value of 15, my P value of 0.53, and I'm looking at an X value of 5. So let me go back to my home screen right here so you can see it. So I'm hitting second vars, takes me to my distributions, and I'm going down to Binome PDF right here. My N value is 15, my P value 0.53, and my X value is 5. So here's what shows up. So I'm going to record to 4 decimal spots. So it's about 0.0661. Okay, my next one here is saying, well, now what about when X is less than or equal to 4? So let me just first define that. X could be 0, it could be 1, it could be all the way up to exactly 4. So here I'm using that cumulative density function. So I'm looking at exactly 4 successes or anything below that. So here I'm going to say Binome CDF. My N value is 15, my P value is 0.53, and I'm looking at exactly 4 successes or less. Let me write that just to reinforce it, 4 or less. So then I go to my calculator. Let me just cover that up for a moment. So here I'm going a second vars, going down to Binome CDF, and I'm saying 15, 0.53, 4 or less. Remember, I use CDF for cumulative, 4 or less. So here I'm getting about 0.0363. Okay, next up, now we're saying greater than 8. Let me slide this up just a smidge right there. All right, so greater than or equal to 8. So that's saying, well, it could be exactly 8, could be exactly 9, could be exactly 10, all the way up to 15 total. So for this one, my CDF only lets me do this number or below. So I'm going to have to go through the complement. I'm going to do 1 minus the probability of it being 0, 1, 2, or anything all the way up to 7. So I have to do 1 minus Binome CDF 15, 0.53, 7, right? Because it's the same 7 or less. So that's what I'm typing into the calculator. So here, let me slide it up a little bit more so I can show you my calculator too. So right here, let me do 1 minus second varse, going down to Binome CDF, and I'm saying 15, comma, 0.53, comma, 7 or less, right there. Okay, so I'm going to get about 0.5935. 0.5935. All right, next up here, x is less than 10, so it does not include 10. So that would be 0, 1, all the way up to 9, right? Because less than 10 does not include 10. So here I can go straight to Binome CDF, 15.53, 9 or less. 9 or less. Okay, so again, what do I type into my calculator? I'm hitting second varse. I'm going down to Binome CDF, and I'm saying 15.53, and here's 9 or less. So that's going to get me about 0.7875. Okay, and then here the last one, x is greater than 6, so here doesn't include 6, right? It could be 7, could be 8, or anything all the way up to 15. So here's another complement one, where I have to do 1 minus the probability of it being 0, 1, 2, all the way up to 6, right? Which is 6 or less. So I'm doing 1 minus Binome CDF, 15.53, here's that 6 or less. So let me type that in, let me just cover it. So I'm doing 1 minus, second varse, Binome CDF, 15, comma, 0.53, comma, 6 or less. So it's going to give me about 0.7735. All right, I hope we're pretty solid on that first example. Let's flip our page over or go to that second sheet. Let me just get situated. And here we go to example 2. So for example 2 here, I'm giving you a situation. So I'm giving you some context. So here I'm saying, according to an article in the American Heart Association's publication Circulation, 76% of patients who had been hospitalized for an acute myocardial infarction filled their cardiac medication by the 7th day of being discharged. Suppose there are 12 people who have been hospitalized for an acute myocardial infarction. Sketch a picture of the histogram, include the window settings, describe the shape, find the mean and standard deviation, and calculate the following probabilities. Okay, so first I'm just going to lay out what is N. Right, we're asking 12 people who have been recently hospitalized. Okay, P is the 0.76. Right, that is the proportion who have filled their medication by the 7th day. So those that have not would be 0.24. That is the probability for failure. Okay, and then X, what values can X take? Well, we could have exactly 0 that filled their prescription. It could be exactly 1, could be 2, all the way up to 12 total. So it could be all or nothing or something in between. Okay, when I make my histogram, right, I already have it set to histogram. So here I just need to kind of make my little chart to the side, my little table, so I can see a few of the items. So here I need to make my L1 go 0 to 12. So I'll just type in a few or write down a few like that. And then for the L2, I'm going to say Binome PDF, my N value, 12, my probability of success, 0.76, and then I'm looking at all the values that my random variable can take, and those are in the L1. So let me first start off by going to my table. So here I want it to go 0 to 12. So I'm just going to go ahead and delete everything afterward. So I have 0 through 12. In the L2, the tippy top, I'm just going to clear it. And then I'm up here. Let me get out of that blind spot right there. Okay. So up in the L2, I'm going to say, okay, go Binome PDF. So second verse, I'm going down to Binome PDF. And I'm saying 12, that's my total trials. My probability of success is 0.76, right? That is the proportion of individuals who are filling their medication by the 7th day of being discharged. And then I'm saying, look at all the different values that the random variable can take. They're all in the L1, right? We could have 0 patients filling their prescription. We could have all 12 filling their prescription, or something in between. So here are all of the probabilities that go with those outcomes. So we see that the early ones, right, super unusual, very small probability, very unlikely. I'm just going to copy down the first few, and I can write it using scientific notation. So 3.7 times 10 to the negative 8th power. Here 1.4 times 10 to the negative 6th power. 2.4 times 10 to the negative 5th. 2.6 times 10 to the negative 4. Okay, as I scroll through in my calculator, I'm looking for where's my biggest probability, and I see this guy right here, the 0.2573. Okay, that one's my biggest probability, so I want to keep an eye on that when I make my window. Okay, if I look at what was 12, that was 0.0371. 0.0371. Okay, so now when I make my window, let me go window, I'm going to set it to 0 here. And then I see that my max, well, my n is 12, so I'm going to go one more, 13, and I'm going to scale it by 1s, so my class width will be 1. For my y min, 0 is great. My y max, well, I had a 0.25 and change, so I'm going to say 0.26, go a little bit above it. And maybe this one I scale it by 0.02s. Okay, it's just showing me the little notches for the y-axis. Okay, I already have it set to histogram, so I'm ready just to hit graph. So when I hit graph, this is what my histogram looks like, right there. Okay, and once I have that, I'm just going to sketch it in my on my paper. So here, if I scoot this over, let me just draw out the biggest bar about right here. And then one that's really close, a little lower, a little lower. Okay, over here, got this bar, over here, here, and here. So I should see that it looks pretty unimodal, again, so unimodal. Our peak, where is it peaking about? Right in here, so at about 9. Okay, and we could say that it's roughly symmetric. Okay, we might say, well, there's a slight skew to the left because the bulk of our data is over here on kind of the right-hand side, and it would taper off towards the left. So you can say slight skew to the left. Okay, so again, just a visualization of our distribution, and then we want to find our mean. And we know where our mean should be, right? It should be right smack in here. It's our balance point. So our mean, we're looking at NP, and our standard deviation, square root of NPQ. So here the mean would be 12 times 0.76. So we get a mean that's exactly 9.12. Okay, and then the standard deviation here, plugging in 12 times 0.76 times 0.24. Okay, square root of that product is going to get me about 1.4795. Okay, so those are the values for mean and standard deviation, but of course I need some context. So over here we'd say something like, in a sample of 12 patients hospitalized, right, technically for an acute myocardial infarction, we'd expect an average of 9.12 patients to fill their medication by that 7th day. So let me keep that kind of short and sweet. In a sample of 12 patients hospitalized, we'd expect an average, okay, of 9.12 patients to fill their prescription by that 7th day. Okay, with a standard deviation of about 1.4795 patients. So again, we're just trying to visualize, well, here's where the mean would fall roughly, right? And then we're just saying, well, how spread out do we expect it to be around that stated mean, right? So how far should a typical value fall from the mean's location, right? That's our standard deviation. All right, so now we have some calculations. Let me slide it up. So here we're saying find the probability that they all filled their cardiac medication. So if they all filled it, we're saying all 12 must have filled it. So X is 12. So I can use Binome PDF. So Binome PDF, I'm using all 12 and then 0.76 and then all 12. So my NPX, 12 trials, my probability of success, my count of success, excuse me. All right, so here when I type that in, let's see if I can slide it right in there. Good. So I can say second verse, go down to Binome PDF. So here I should have 12, comma 0.76, comma 12. So that gets me about 0.0371 as my probability. Okay, next I'm saying less than 7 filled their cardiac medication. So we're saying that X could be 0, 1, 2, all the way up to 6, right? Because it's less than 7. It does not include 7. So here I need to use that cumulative function. So I'm using Binome CDF 12.76 and then 6. Because here it's 6 or less. Okay, take a moment. Why don't you type that in? You can pause for a moment. Okay, type it in. And then check that we match. 0.0453. Okay, next up, more than 9. So more than 9 filled their cardiac medication. So first I'm going to flesh that out. More than 9 means it could be 10, 11, or all 12. So here's one where I'm going to want to use that complement again. So I'm going to do 1 minus the probability that it's exactly 0. 1, 2, all the way up to 9. So 1 minus Binome CDF, we should have a 12.769, right? So 9 or less. Okay, why don't you pause for a moment? Go ahead, type that in. Make sure that we match. Okay, and we should get 0.4222. All right, 2 more variations. So at least 4. So at least 4, what does that mean? Right, at least 4 means it could be exactly 4 or 5, all the way up to 12. So again, I'm going to go through the complement and do 1 minus the probability that it's exactly 0, 1, 2, or 3. So 1 minus Binome CDF, 12.76, and 3. So again, that 3 is 3 or less. Okay, let me show you how we can type that in one more time. So here I'm doing 1 minus, second verse, going all the way down, Binome CDF, so 12.76, and then 3 or less. So I'm getting about 0.9997. So very likely that this scenario would play out, almost 1. Okay, and then last one, at most. So at most 10. So let me flesh that out. So it could be exactly 0, could be exactly 1 or 2, all the way up to 10. So here I can just go straight to the Binome CDF function, Binome CDF, and then 12.76, and then 10 or less. And I keep writing this just to really reinforce that it's looking at this exact count of success or anything below it. So I should, after I type that in, should get 0.8222. All right, I'm hopeful that that all made sense to you guys, and I look forward to seeing you guys soon. Have a good day.